morning, everyone. Thanks for joining here. And I want to thank the Riches here and the team at Bales for getting this organized and kicked off, and hoping we can do more stuff like this in the future. My name is John Carlson. I work with Wisconsin Engraving. I've been here about 6 months now, but I've been working with Pete, Tom, and the rest of the guys over there for probably north of 5 years now, something like that. I've been in the industry, I don't know, pushing 10 years now at this point. My background here and how I got in the industry actually was with GF Machining Solutions, or Agi Charmy, however you know the guys. Was there for almost 8 years, where my specialty was the advanced manufacturing technologies, which was metal 3D printing, laser micromachining, and the 5-axis laser texturing, which is what we're going to be talking about today. So again, thanks for joining us. Thanks for having me.
Thanks for being here.
And then, like Rich said earlier, please, if you got questions, interrupt us. Much rather have that than death by PowerPoint. So you're not going to be pestering either of us if you've got questions. So please ask them.
All right, let's get this train rolling. Well, just to give you a little overview of what Bales offer, we offer 4 types of nickel and 2 types of chrome. We also do mold polishing. We also offer mold blasting or component blasting. So that's just it in a nutshell. We'll go into detail on individual applications that may aid in the texturing aspect to protect the life of that substrate. So we're just going to pass it on to John so he can give a little overview of Wisconsin Engraving.
So Wisconsin Engraving, we're located just outside of Milwaukee. We actually just celebrated our 100th year anniversary at the end of March, March 23rd or 26th, whatever the exact date was, but we're 100 years old now and celebrating all year this year. But to kind of get into the guts of it here, what we're known for is engraving, texturing, that's more of the traditional chem etch texturing, mold polishing or component polishing, machining, and then you can see the laser on the far side, which happens to be my specialty and what we'll be talking about today.
All right. Well, some of the things we're going to go over today is laser texturing 101, metal laser texturing application and emerging trends, the benefits of metal laser texturing, and how an engineered coating can protect those metal parts. It's up to you, John.
Thank you. So one of the things I always like to do when I'm introducing the laser to customers is kind of get you into the right headspace. When you're talking with lasers with customers for the first time, especially the laser texturing, the automatic default is to go to the laser cutters like you're seeing here, the CO2 cutters, or just the simple laser engravers like you're seeing on the far right here, putting serial numbers and barcodes. Doing the serial numbers and barcodes is something that we can do, but it's not something necessarily you would want us to be doing unless it's involved in a far bigger project. And then the third smaller picture would be laser micromachining. So it's the laser cutting just on a smaller scale. And that's not really what we're talking about today. Okay.
Oh,
hopefully
we'll figure it out.
We'll see if these videos play or not.
Yeah, it should.
So another thing I always like to do to kind of help people get into the thought process here, maybe I can get both plans at a time. It looks like I can.
Oh, that's crazy.
That's a little crazy. To kind of help people get into the right frame of mind here is 3D printing. Everyone is abundantly aware of what it is and how you do it, especially with the one video on the left here, where you're stacking these layers to get your 3D geometry. What we are doing on the laser texturing, laser ablation side is we're doing the exact opposite. Instead of building up, we are doing layers and burning into the steel, burning into the aluminum, burning into the titanium. So it's a similar process, but just kind of, I'll say, inverted. So we want to burn into the steel or the metal substrate that we're working on here. Now it's gonna play the videos.
I told you it would.
There we go. So what I want to do is kind of go through real quickly kind of how the process works, some of the emerging trends that we are seeing ourselves, and then what we are hearing from the OEM and customers as well. And then we'll go through kind of a couple applications that we can talk about as well. So the process is extremely digital. What we need on our side is the CAD of the actual steel or aluminum part that you have. And then we would work with you, work with your apps teams to discuss where the selection features, where do you want textures or where do you want functional or cosmetic features put into the mold steel or mold aluminum. And then do you want one texture? Do you want two textures? Do you want three textures and an engraving? What are you looking for specifically? And then we can do all that stuff digitally.
Does it matter what kind of format that CAD data is in?
We don't particularly care. Typically, though, we want it as native as possible. So if you're working with SolidWorks, send it to us as a SolidWorks file or an IGES or a step file. The more accurate the file, the better off. The better the results are that you're going to get. It's just,
okay.
It's kind of the easiest way.
Just curious.
So we move on here. So we work in grayscale just to kind of simplify it. If you really want to look this up and you got to, while I'm talking here, want to go to Google, look at what's called a depth map. Depth map gives you kind of those ghostly images. But what that gives us the ability to do is an area in that black and white file that's white versus an area that's black. Is that allows us to set our depths. Okay. So if you came to me and said, John, I want this carbon fiber feature burned 10 thou deep. What we will then do is plug that into the software, and the software will look at the deepest, darkest black pixel in that artwork and set that as at 10 thou.
Okay, that makes a lot of sense.
And then as we go to white, or those grays to whites, that sets our depth. So the whiter it is, the less the laser hits it.
Okay.
And that allows us to get that contrast and definition that a lot of people are looking for.
That's pretty cool.
And because it's fully digital, if it's black and white one way, you don't like the way that it looks, you can say, hey, John, inverse it, and now we can go white and black. And it's as simple as that. I'm going to talk about morphing in a minute here, so I'm going to skip it here because I want to go back to this. So this is a very simplistic way to look at the laser versus more of a traditional ChemEtch kind of technology here, or just laser in general. Let's say the more layers we can add to a burn, the more definition and the more quality you can look at here. So you can see the three images on the bottom. The bottom left was only hit 5 times. So you can see it kind of looks like leather. You can argue that it doesn't. Where the second one was hit, I think 20 times. The formatting moved on me here, but it's starting to look more and more like leather. Where the one that was hit 50 times really looks like leather.
Yeah.
To the point where if you touched it, you would almost think that's leather.
Yeah,
no way
to achieve your certain finish, you've got to do the layering, just like in EDMing and things like that.
Correct. Yeah, it's how many times you strike it or how many times
Perfect.
you pulse is same thing here. So what we could do is we can set how much material we're removing every time we hit it with the laser, and that's where we're really starting to fix those depths and dimensions here. What this technology also gives us the ability to do, since we've brought in-house, we've had this laser in-house now about 5 years, is it's really given us a opportunity to come to our customers with a more encompassing approach. I know it sounds very salesy. It is a very salesy kind of conversation, but it does give us the opportunity to talk to customers and give them exactly what they're looking for. In the instance that you're looking at here, this is a mold piece here. You can see it's taped off on the sides where that blue is, and then where the black paint is chemical resist. What we're doing here in this instance, with all of that surface area, that's a lot of surface area for the laser to be removing, especially for the depth that the customer wanted on here.
Sure.
So what we did instead was we put the chemical resist on there, put it into the laser, and have the laser remove the chemical resist, and then we can then take it into the chemical baths, and then we get the best of both worlds.
Sure. Yeah, that sounds awesome.
The other thing that this allows us to do, as those 3D surfaces are constantly changing, trying to stretch and get films on there can be done. It gets to be difficult, especially when you're dealing geometrics. If geometrics get stretched or pinched or misaligned, the human eye is really good at seeing that stuff. It's kind of a pain in the butt, to be honest, but we're really good at noticing stuff like
Yeah,
that.
and especially in the industry, you guys see that where, like, me as a normal consumer, you look in your car and you got all those different textures, and if there's a mismatch, personally, I would never see it, but you guys, I'm sure, would catch it right away.
Yeah, but I mean, think about it, you're in a car all day, every day. I mean, like, as sales guys, and we spend a lot of time in the windshield. I mean, you would start picking up on that stuff. You've got a car for 10 years. You're going to see where misalignments happen in textures. And, with our customers, with the designers that we work with, misalignment is unacceptable.
No, right, exactly. You can't have that.
You can't have it. And they know where to look and where to, where to dig you on it too, a little bit.
That's that quality person's job.
Yep. So this is coming back to that morphing that we're talking about. Because the process is fully digital, we can do really unique patterns like this. There's 3 unique patterns here on this image here, where we've got the leather grain to the golf ball dimple on the bottom right to the pyramid or like a knurling style pattern on the bottom left here. Doing this traditionally with chemical would be nearly impossible, if not impossible to do. You got me.
Sorry. Spreading the love.
but having multiple textures like this done traditionally is very hard. Like I said, nearly impossible. But with the laser here, you can see that there's a smooth transition from one to the next. There's not hard starts and stops where one texture starts and one next one stops. Again, if you can design it in Photoshop or Illustrator or GIMP or SolidWorks, it more or less can be done with the laser.
Okay, makes sense.
This is always a really nice slide I like to end on, at least for this initial kind of conversation with customers, is if you want the laser to do blast or EDM finishes, we can do it.
Really?
To the point where you can call out an EDM finish and we can digitally pull it up and say, here you go.
So if we want a VDI 12 or something, you guys can do that.
We can do it.
Perfect.
Geometrics. People love honeycomb. I don't know why. Design people just love it. I think it just gives them so much flexibility here. The image here, this texture here in the shop for us, we like to call this the Inception texture. So if you've seen the movie Inception with DiCaprio, you can see there's honeycombs inside of honeycombs inside of honeycombs. That's why we call it the kind of the Inception texture when we're talking about stuff like this in the shop. Other ones that we can do as well, you can see the bottom left, lots of naturals, organics, naturals being, leather grain, wood grains. You can see the leaf in the bottom right. Lots of textures along those, brushed steel, brushed aluminum, those types of looks as well can all be done via laser. And the bottom right one is always the one I like to, when I'm in front of customers, I always love this one, because this is when you got the design guys in-house, it's how creative are you?
Mm-hmm.
And that's usually the brain melter. It's like, what do you mean?
Right.
What can you design?
Sure. Yeah. And then look at the fine detail there. I mean, that's crazy.
Our biggest limiting factors when it comes to laser is really 3 things. It is, do we have a line of sight with the laser to where you want it to go? I can't tell you how many times I've had to explain to customers, I can't get the laser there because there's a block of steel in the way. I can't go through the steel to get to that. Sorry, it doesn't work. So if there's undercuts and stuff there, and if you're on the inside of a mold cavity and there's an undercut there and I can't get to it, I can't get to it. Sorry. The second limiting factor is how deep do you want to go? Okay. For us, the deeper you want to go, the more expensive it's going to be for you, because the longer it's going to take for us to do it. So there's always a trade-off there.
Sure.
But frankly, for us, about 80 thou or 2 millimeters is about as deep as we want to go with the laser. Anything more of that, go with your traditional milling, go with the chemical, go with EDM.
Okay.
It just gets to be too much unless it's one small feature. But if it's a whole mold plate, removing that much material just takes so much time.
Yeah, it's that. And I'm sure the price would be, you know, it wouldn't be cost effective for
No.
everybody to do that.
And that's part of the conversations we can have with customers. They'll bring textures in and say, John, I want this at 3 thou deep, 30 thou deep, sorry, 30 thou? No, whatever it is. I'm blanking out what it is now. 2 millimeters,
It's deep.
2
He
millimeters,
says it's deep.
2 millimeters is 80 thou, so anything over 80 thou. So let's say 100 thou deep. Mr. Customer, do you really need it on the laser? Because at that point, we think this needs to go EDM. We think this needs to go million. That's
Yeah, and those
conversations
are
that
the
we have.
conversations you gotta have. Just like with us, you've got to know base materials, you've got to know things like that. Those are important questions that you need to ask up front.
100%. And one of the other things that we talk about customers, or I talk with customers about a lot, is feature size. Most customers are used to what's the smallest end mill you can get? 5 thou, maybe a little bit smaller than that. I mean,
Yeah, take that out of the box without breaking it.
yeah. So what we have on the laser, we pretty much run standard in the shop, excuse me, 2 or 3 thou laser. We have the ability to do 1 thou, or we have 30, 50, 75 micron spot sizes with the laser. So if you're getting to feature sizes smaller than 30 microns and you want the human eye, or it's a cosmetic feature, do you really need that? I mean, are you going to see it? I mean, that's always my question. If you're getting into functional stuff or like medical and you want smaller stuff, there's other shops I can point you to. That would not be us doing that.
Sure.
It would be different laser sources, stuff like that. But that's, you know, that's conversations we have to have with engineers all the time. Just because you can design it that small doesn't need to be that small. So we're willing to have those conversations, and we have them frequently. Okay, so some of the emerging trends, again, this is stuff that we are seeing and stuff we are getting as feedback from customers and OEMs. So automotive, the big stuff here is like mold and die or packaging. How can I make my product look sexier and different than my competition?
No, right. You want to have that mustard bottle that looks better than everybody else.
Yeah, now I could charge a premium and charge an extra for the mustard bottle. I can charge an extra $1.50 because it looks better than my competition. So we're seeing a lot of people playing with different types of finishes for headlights, automotive headlights. We have projects going right now with some automotive OEs where we had this conversation with them, and now the designers, our wheels are spinning to the point that they're going outside and they're 3D scanning the asphalt out in the parking lot and having us burn it into aluminum. And it looks like asphalt and aluminum. Different group grabbed a piece of computer paper, crumpled it up, flattened it out, and 3D scanned that surface. So now you've got all these facets at different angles.
That's crazy.
So when you get that in steel and aluminum and inevitably into plastic, when you're looking at it, the way light is hitting it as you're moving around, you're kind of getting that light is moving around effect. Automotive, we're also seeing functional stuff. So think of like a steering wheel, the back of a steering wheel. When was the last time you looked at the back of your steering wheel?
I have paddle shifter, so sometimes.
Well, I mean, okay, minus Rich here. How many of you have actually ever taken the time to look at the back of your steering wheel? None of you would be my guess. Or if you got Rich, I'll give you 1% here.
Thank you. Thank you. I am
You could be
special.
the 1%.
I am special.
You're the 1%.
That's what they say here. I'm special. I don't know what that means.
With applications like that, you could do a functional texture on the back of your steering wheel, so you're getting better grip.
Yeah.
But as you're coming around to the front, you're getting cosmetic surface now. So now you're getting the best of both worlds. So you got buttons and knobs in there. Okay, they don't necessarily need to be cosmetic. They just need to be functional. I want to make sure as my customer is driving and he's trying to turn up the air conditioner, he's got stuff to grab onto.
It's not sweating. Right.
Exactly.
Perfect. It's all good stuff.
Last one here. I mean, medical, a lot of that is functional and stuff for like orthopedic implants, stuff that we don't do ourselves, at least for medical implants. You're talking tooling and devices and stuff like that, and you need textures for functional purposes in there. Absolutely. The last one on the right here that Rich can't see and I can't see, but I know what it is.
Are you sure?
Yeah.
Okay.
Is anti-counterfeit. This is a very unique application. I can't talk too much about in a open format like this. If you want to learn more about this particularly, feel free to reach out to us, call me, email me, and I'd be happy to have a more in-depth conversation with you. But basically know that talking too much. Know that
You're doing a fine job.
it is.
I'm talking at the end.
There you go. It is. We can take a texture, put features on top of it that you can't see with the naked eye. You can't even, you know, if you blew it up, you would never see it. But know that your phone can scan it, look at it, and pick up on that anti-counterfeit feature. I've got one. Thank you. So some of the application examples I have here, I'm probably going to spend more time maybe on the mold and die packaging here and kind of maybe run through more of the other stuff here, unless you guys stop me or Rich
No,
stops me
no,
here.
this is a lot of the industries that you guys deal with, you know, we cross merge here at Bales. We do a lot of the same customer base and things like that. And, you know, you can just jump in and do your thing. And we're going to explain a little bit later how to protect this investment when you're spending these thousands and thousands of dollars, what we can do to help.
Perfect. So the first one here is a real easy one to kind of wrap your head around. And I have one right in front of me right now. Came right off my water bottle. I mean, it's putting the serrations into the steel you're seeing on the image in the bottom left there, putting the engraving and textures to put a texture on the top of the cap here, to the point of even doing the thread pitches on the inside of the cap. Stuff that the laser is more than capable of and does constantly, does all the time. It's pretty simple application. It's stuff that we do all the time, especially in the packaging. And, you know, as small as this is, it makes
So
sense.
you guys
to
can actually laser the threads?
Yeah.
Interesting.
I think that's right there.
Oh, well,
There you
there you go.
I thought I had
That
I thought I
answers
had
my question. I was trying to figure out how you're gonna get in there,
Yeah.
but now I can see how.
Yep.
It's a split.
It's
Yeah.
a split.
Okay.
But if it's a full piece of steel there, depending on depths and stuff,
And then
because it's
angles for
5-axis, we can come in at
Okay, all
angles.
right, well, that makes sense then.
Let me skip.
Hey,
ahead
John, what
here.
kind of finish is required for that?
Oh, good question. This is kind of I'll be honest, a cop-out answer. I'm really good at those. It is, the better the surface finish is of the aluminum or steel going into the laser, the better the surface finish is coming out of the laser. So let me dive into that a little bit. If you come to me and say, John, I want a 10 RA finish on my bottle mold here, I'm giving it to you as a 10 RA. Okay, Rich, are you sure you want to give it to me that way? Yes, that's what I want. Okay, we can try our best to maintain that service. In most applications, we more or less can. It's going to take us forever to do.
Okay. And you challenged those requests? You guys,
Oh, 100%.
Okay, perfect. Same with us, you know, are you sure you want that surface finish? You know, that's key here because we both businesses, we
Yeah.
do mold polishing. and polishing.
The caveat here being, okay, you wanted it at a 10 RA. Rich, can you give it to me at a 5 RA? Can everything be 5 RA, but where we put in the texture, we can go to 10. If you can go to 10, you gave us that, you know, 5 RA of value to work with.
Sure.
That allows us to run the laser faster.
Okay.
So that would be a significant, I don't want to say significant faster, but it would allow us so much more room to bring that RA back that we can run it a lot faster and more aggressive, where if we have to maintain what's on there already, we have to run it slower because we have to remove so little amount of material at
And
one
slower
time.
probably means, you know, added cost
It's
and
more time. Yeah.
and just like anything, time and material is key.
Yes,
Yeah.
100%. Another nice kind of real world application here. If you see in the top right, I live in a house of these things. I have a 5-year-old at home and who just destroys applesauce all day, every day. So those little Mott's applesauce cups that look like it's the wicker baskets of the apple bales. We do that on the laser every day. I can't tell me how many of those I've seen in the laser machines this year in the shop, but that's coming from us. That's us doing that work.
I'm about to buy some applesauce now. Just to look
I
at
need to
that.
go get an
Yeah.
apple orchard just
There you
to
go.
feed my daughter with these stupid applesauce, but that's a different story. But real world application, you got the Mountain Dew bottles, you got the Pepsi bottles, you got the Coke bottles that all have those textures in the handles there. Laser. It could be done laser. It is being done laser. It just depends who's doing it.
Right. No.
Okay, this is another real couple real world examples here, and I just like kind of showing the different depths and features and stuff that we can do here. So the one on the far left, again, it's going back to a bottle mold here, but it's just kind of a random geometric pattern at different depths. The one in the middle here is a strawberry basket. So it's that really thin wall plastic packaging here. And they were having the milling marks show up in the plastic.
Okay.
So we went in with the laser and just did a VDI blast here and allowed them to.
So how much of the surface are you removing? Say you've got that clear area, and then now you've got your lasered area. How much are you really actually removing?
It depends. I mean, how deep or how shallow do you want us to go? Do you want us to remove? Do you want us to remove a tenth at a time? Do you want us to remove 1 or 2 microns or a micron at a time, or you want us to remove several microns at a time? It really just depends on application. What do you want, Mr. Customer? What type of finish do you want? Blah blah blah. So these are all conversations that we have with you guys
So
constantly.
when somebody builds a cavity block or core or whatever, they need to, compensate for whatever laser, just like what,
just like you would with any
machining,
texture.
polishing, whatever.
Exactly.
Okay.
Yeah, you're gonna want to have more material so we can remove back to it.
Okay.
Unless that mating surface or that main surface and we're etching back, I mean, it is what it is.
Okay,
So,
yeah, I kind of figured that, but I just thought I'd throw it out there in case somebody was, new, trying to learn some things out there.
And then the image on the far right here, that's a thermoform image. It's think of like your Hungry Man dinner trays. You microwave and you've got some texture on the bottom of those trays. I really like to keep that in there because it shows, well, one, the variance of all the stuff that we're doing, but having the ability to have those diamond pattern textures follow those contours seamlessly and flawlessly.
Hey, Rich,
Yes.
what coating would you suggest to put on that textured cavity there to help it kind of release a little easier?
Well, that looks like it actually looks like an aluminum piece, so I would lean towards our NIBOR coating for release. The coefficient of friction is 0.05 or less, so it's pretty slick. And what's nice about our coating, the NIBOR, you could put it as little as 50 millionths up to about 0.5 per side. So now you're not going to distort your surface finish. So whatever you texture or whatever you put in there is not going to be distorted. It's going to mimic that surface.
So you're doing the same thing, basically. It's similar kind of thought process, but it's different of what we're doing to the laser. So going back to kind of that surface finish is, if you're sending me, okay, we're blowing it up a million times here. If your surface finish looks like this, okay, we're not taking an end mill and flattening that surface out.
Correct.
That's just not what we're doing.
Right.
So if we've got this surface, the laser is going to follow that contour.
Same with our coatings.
Exactly. And that's, now you say that, really fires up random neuron.
It will mimic that surface.
Yeah. So the laser is going to do the same thing. I mean, we're using the laser to, hide that stuff a lot of times.
Yes.
But that's what we're doing with the cosmetic and functional stuff. You're doing it on purpose. So automotive, this is really where design people are really starting to play with it here. It's playing with depth, like you're seeing on I'm gonna call it the carbon fiber weave. It's not really on the far left there. And then you have other groups playing with the matte finishes versus the high polish. So it's really coming down to, again, how creative is the art team that's developing
exactly.
this stuff.
And there are so many fancy graphics out there now. It's crazy, and you guys can mimic any of that.
We can develop it for you. I mean, if you had a customer that came to us and said, hey, we kind of think we want this, can you help us develop it? We'll do that. That's part of what we do. We've got graphics teams and graphic designers in house that can help us work and iterate with you to get up to what you're looking to do.
That's cool.
This is always another one I always really like to see. And Rich, I apologize, you can't see it here. Our faces are right where the image is here on the far right side, but
that's all right. That's all right. I can watch the replay.
There you go. Customers in automotive, especially for like the LEDs on the inside of your car, instead of it just being like a dot, with the light coming through, what they're doing is they're playing with the surface of that lens that's going over that LED to disperse that light.
Okay.
So they can have it just be dispersed. They can have it be dispersed and have it be like a diamond pattern. It could be a bunch of different lines coming through. So you can really start to play with, how does that light actually look coming through that lens, and you
That
can
lens.
start picking and choosing what you want it to do with that light. More decorative here, you can just see kind of what it looks like in the steel and then what it looks like in the plastic on the side mirrors here. This is another one I always like to really point out. We were kind of talking about this earlier with the mismatch of
Right.
geometries here. Okay, so we got two different molds here, two different pieces on a dashboard. So think of on your dashboard, you've got a lot of the cars have the storage up in the dashboard now. This is kind of the same concept here, where we've got two different molds and a geometric pattern. Where in the past, if we were trying to lay this with films, but it's going to be two different molds, good luck
Yeah.
getting those to line up correctly. Where with laser, we can do all that stuff digitally, make sure it lines up, and then just separate everything digitally, even though separate
Yeah,
molds.
taking that CAD data and then transfer it. Yeah, that's
100%.
That's crazy.
I always like to leave this one in here. Engine covers, we do a lot of engine covers actually at the shop. And the big one here is you can see this dimple pattern as the surface is constantly changing. You can see we're not getting any distortion or
Yeah, the depths all look the same and
yeah,
everything.
there's nothing stretching or pinching or
Right.
off here, and
Right.
that's due to the 5-axis capabilities that we have and the software control we have, frankly. This is a cool one. So this is an example of someone who was doing cosmetic with functional textures. So the cosmetic are those two small ones on the bottom there, where it's just, hey, I want this to look good.
Mhm.
Where that kind of Y or V shape is a functional texture. And the function here is, okay, you're on the road with your motorcycle, you're behind a truck or a semi truck or whatever, and it's raining out and it's kicking water up on the front of your motorcycle, and the water wants to come up the windshield. What this texture is doing here is as the water hits that texture, it's taking it out to the sides
Oh,
and not
that's
allowing it
crazy.
to come up to the top here.
Who would have thought of that?
So that's the thought process there, is that, okay, you're still gonna get rain that
You're
hits
still
the
gonna get
windshield,
wet, right?
but it's reducing how much is there because you don't have a windshield wiper.
That is crazy.
Again, just contour control here, so I'm gonna keep moving here because I know I'm getting a little long-winded here for you.
No, you're doing a fine job. I'm just sitting here relaxing, this being on camera, waving at everybody,
There you
saying
go.
hello.
I always like to leave this one in for the old school guys out of Detroit. Okay. My generation, the generation younger, okay, we grew up in mom and dad's car that had the wood grains and leather grains all throughout the car. Okay. The next generation of kids who are starting to buy cars now don't want that leather grain and wood grains. That's what mom and dad had. I want
Right.
the geometric patterns. Okay. But you still got the old fogies, I'll say, in Detroit that really still want that look and feel of leather without it actually being leather. So
What's considered old fogey?
I'm not commenting on
Okay,
that.
I
Come
just
on.
wanted to just clarify. that.
No comment. Let's leave it at that.
Thank
But you got some of those. How about this? Traditionalists.
Traditional.
There you go. Some of the
Okay,
traditionalists still want that look and
That's
feel
beautiful.
of leather and being able to duplicate that. Okay, it looks like it's hand stitched, but it's really not.
No, that looks awesome.
Okay. In a room full of manufacturing people, if you got more than 2 people in there and you either got a gun piece or an automotive piece, you're golden. So I always like to leave this one in here. So being able to do this stuff in firearms. A lot of people want to go out and purchase their first 1911 or their 100th 1911, but they want it to be engraved. What we are starting to see with this is the guys that can go off and send their guns to Italy and have it be hand engraved by, some famous, engraving artist can pay the 10K and wait 3 years to get it back.
Sure.
Okay, Joe Blow, me, I bought a nice gun I'm really happy with. I want to get engraved. I can't afford 10K.
It's more than that costs itself.
Exactly. So what we're seeing vendors and customers do is they now can offer 2 levels of engraving below the hand engraving. They can do one that's called hand engraving,
Okay.
where it's 80% done via laser, and the final 20% is done hand engraved. They can still say their gun was hand engraved, even though the laser did the bulk of the work.
Mhm.
And then there's the guys that I just want it to look cool. I want it to look the way I want it to look. We can just do straight laser.
Sure.
And then you just got the guy who bought the gun.
I mean, look at the detail. That's crazy.
So again, the big one here is the flexibility the laser gives you with the artwork, and then the ability to wrap it around
No,
in
right,
3D.
exactly. Like the flag there. That looks, it looks real.
So the flag there, actually, the coloring that's in there was all done via laser too. So we can do, I call it like a local heat anodization. What if you took a torch to that steel or whatever that material is, what other colors you can pull out of that? You know, the blues and the straw colors, the reds is what we can do with the laser.
Okay.
It takes some sampling to do because we need to know the material, what colors we can pull out of there. But once we know that, we can actually pick and choose where we want those colors
Okay.
on the steel.
That's cool.
Please note that if you want colors in your mold, we're happy to do it, but it's not going to transfer to the plastic. I have to say it.
That's probably a good thing you say it.
Yeah.
Yeah.
Roll dies. This is a big thing for our shop here. As some of these roll dies are getting to be, I don't want to say more complicated, but more or less of the wood grains and leather grains going back to these geometrics here. This is where we're starting to do a lot of that hybrid work that we were talking about earlier. It's putting the chemical resist on there, have the laser come in here, remove it, and expose the steel underneath it.
Okay.
Which is like the one
Just
here
like that?
on the bottom right here. Where you get the best of both worlds, or we can go just straight via laser and give you that depth and definition you're looking for. Really good real world example for this, other than, you know, toilet paper, paper towels, which everyone's used to, is the plastic decking that you've got in the back. Okay, it's got that wood grain in there. It had to get squeezed into there somehow. That's a really good example where this is coming.
Perfect. Good stuff.
Miscellaneous here. I'll end on this one and then.
Are you sure?
Hand
I
back
mean, you're
off to
doing
you.
fine. I mean,
I'm a sales guy. I could talk all day.
I know you can.
This is a really nice example here of the flexibility that this really has offered us. So you've got the honeycomb on the side there. We got the different VDI finishes there, or sandblast or grit blast finishes. And then you could see the little pluses in there as well. So this was a piece that was milled, polished, and then lasered here. For us, or anyone else on the webinar here, you can see the pluses there because we were able to program it into the program. Don't laser here.
Okay.
So now we don't have to mask all those locations that are polished that we don't want the laser touching. So we don't have to have humans touching this anymore. So we can have more accuracy, repeatability with this than maybe we would in the past. So this was what you're looking at here, all the different VDIs and the honeycomb finish here and the engraving in the middle was all one program, one setup for us.
So when you guys set up a block, you guys pick a reference point, and when you program your laser, is that how it is? Is you guys center off of the center, off an edge, or?
So we for sure, so if we have like a mold base, we'll do the XYZ touch up and then just to know where it is in space. And then if you've got some like dowel pin holes in there or through holes in there, hopefully that aren't angled, we can then go in and do touch ups on there. So we get our skews then too.
Yeah, I just thought that'd be something for people that are out there, that it's, you know, as simple as you get your block and you machined it right. And you send the CAD data that matches, you should be able to achieve these finishes.
The best way to think of this is think of a really high-end 5-axis mill. Take the spindle out, put a laser in.
Oh, that's
it. I mean, that's what these machines are to a T.
Perfect.
So just a couple more examples, just to kind of take a look at honeycomb and side of honeycomb. So the inception texture again and again, the steel brush finish here. That's on stainless, actually. No, that is stainless. And then some deep engravings here.
Sure.
And then we've talked about this a bunch, being able to duplicate EDM finishes here.
Yeah, so now I get to talk. Wow. Well, at least, you know, put my 2 cents in there. So why would you coat your textured metal parts? You know, primarily it's to protect the investment. You can just understand from what John had said, the kind of time and, you know, precision that goes into this. And you don't want to have something, you know, like running the wrong material or just anything to destroy that. So what we can offer you is, you know, repairs are costly and you've got to protect your investment. You know, say you've got a part that's sticking, we can help aid in part release. You've got the materials, you know, that are abrasive. There is a lot of material out there, especially in the automotive industry, that has 30, 40, 50% filler in it. That can really attack the substrate. So now you've spent all this money and you got this nice textured detail, and say near the gate area, end of fill, and now you've got this gassing, and now you're just going to wear that away. Yeah, we'd like to protect it. I'm sure they would love for you to send it back and get it retextured. However, you know, you're just choosing the way to protect your investment is key. You know, corrosion, you know, just the environment we live in, you know, some shops, they spend all this money on these tools, and you go in there and they're not climate controlled. I can tell you how many places I've been to where you walk in and it's like a sweatshop, and you have hundreds of thousands of dollars of tooling, you know, sitting on a shelf, and then the guy takes it apart and it's just all rust. So, and now you've spent all this money to make this pristine part, and it's destroyed, or you're starting from scratch. You know, coating the tool typically will lead to about 30% extended life. So these are the things you need to think about when speccing out a tool. You know, typically, you know, laser texturing is one of the end of the line things. You know, after the mold maker used up all this time, you never hear that.
Never.
So then now he's just used up the last 5 days that they had, and then they say, oh, by the way, let's get it plated. So now, you know, these are things you need to think about when you're building a tool, or like refreshing or PMing your tools, to include some time for your texturing or your plating or polishing, whatever it may be. What coatings are ideal? I would lean towards, you know, electrolysis based coatings, because they flow evenly within 50 millions. 50 millions is nothing. So it's not going, like we went over here, we did the roller coaster peaks and valleys. You know, it's going to follow that. It's going to mimic that. You're going to achieve that finish. It's not going to really affect your gloss level and things like that. So our coatings will mimic and look like a steel component. So, you know, it's just something to think about. So you have a sticking problem, nickel boron nitride, or NIBOR, coefficient of friction 0.05 or less. It is slick. So you build a tool, and say you build it with no draft, and now the part is sticking. You know, these are things, both of us, we've been in the industry for a little while. You hear these things and you're like, why would somebody build this? Well, you know, well, the engineer, you know, we're not going to go down that road, because, you know, I was a mold maker, so we love engineers that are out there. So, yeah, just things to think about, you know, up front. I mean, we'd love to have the planning ahead of time. However, we know a lot of times that okay, you've sampled a tool, and now, hey, I've got a sticking problem, and hey, I need to get parts to my customer. Well, we can offer some solutions to help you. You know, depending on our workload, there are things that we can turn around quickly and things like that. But however, you know, you just got to make sure planning is key. So you've got that abrasive material, and you've got some of those weird details, you know, geometry that's hard to get to. Our diamond EM with a post bake with a 70 Rockwell. What's nice about that? It gets down in there. Chrome, you'd have to build an anode. Odds are you're not going to get into those deep ribs, deep pockets, deep details, and it's going to miss. And, you know, typically what happens with abrasive material, it's going to find that spot that's not coated, or that area, like I said earlier, the gates, end of fill, your vent, those are going to wear typically the fastest. And you want to protect those, and especially those abrasive materials. Diamond EN would be the way to go. Okay, so now you've got a textured part, and it's you're running something that's more of a LSR or rubbery material. Nickel-on is the way to go. It's a nickel PTFE. It's great for those 50 durometer or less materials that tend to be sticky during processing. And I can tell you now that certain textures, or even EDM finishes, you know, some of our customers see problems when they run those types of materials with parts sticking. Okay. And now you're peeling that part out, and now that texture's been distorted. So with a nice release coating, it removes from the cavity nice and easily. And then you don't have that issue where, you know, you've got or ejector pin pushing, you know, making marks on your parts. You know, chrome and diamond chrome, when you get into texturing and even EDM finishes, I mean, it can get a little tricky because it doesn't flow quite as evenly as the electrolysis nickel-based products. You may run the risk of maybe losing a little bit of, especially on the edge, you'll get some edge buildup. So you may lose some of that detail, especially if it's critical to keep that all at one surface dimension. For the most part, you know, the key is, you know, protect your investment. I mean, we can't say it enough, you know, let the coating take the abuse. I mean, you've spent you know, a lot of money on these tools or components, whatever it may be. And the key is to, you know, make them last a good long time. And, you know, ideally you want a tool to last a few years. You know, we have some customers, you know, have a couple 100,000 shots on textured parts. And we have another guy that we know that has an aluminum tool that we coated with our nickel boron that has over 7 million shots. So, and that's only 2/10 thick, but he's running just, you know, regular nylon. However, he protected that substrate, and that's the key here. Any questions for myself or John or the other Rich? 7 million hits. Yeah, it's crazy, and it's still running. It's probably even more than that now. Rich, have you seen anything come through the chat?
No, sir. No, there's not a whole lot. There was a question about how thick of a coating you can go up until, that just came through.
Okay, well, typically with the nickel-based products, we like to go right around 7 or 8/10 thick. Chrome, you can go a little bit more, but now the more you put on there, you run the risk of you have to do some remachining because you're going to have an uneven, depending on if it's over a larger surface, your edges are going to be, say if you needed 2/1000 overall, you'd have 2/1000 on the edge and you may have only a 1/1000 in the middle. So it kind of just depends. Ideally, we typically like to do most of our coatings at 2 to 3/10. That's where we do all of our testing. But however, we can go as little as 50 millionths because, you know, you've got that pin and you don't want to mask and you've got a fit problem or you have a tolerance issue. Those are some things you need to look at.
Well, here's another one. What base materials can you plate on?
Well, typically the base materials we can plate on aluminum, mold max, beryllium copper, stainless steel, all the carbon steels, titanium, carbide tend to give us fits. Even some D2 steel, especially in chrome, tend to have some issues with adhesion, but D2 is fine in nickel.
How about you, John? Are there any limitations for base metal for texturing?
The only, I mean, we want to stick in metals for sure. Organics, so like wood, we don't really want to be dealing with. Most plastics, we don't really want to touch. Honestly, we either burn it or melt it. Other than, yeah, I mean, other than that, the only other metal I would say that gives us issues, and I'm gonna say issues, is copper, which we can machine. It just takes longer. And it's because of how it absorbs light. It's like 80–90% reflective. So we're like aluminum is like 5% reflective. So it absorbs light really well, where copper is very reflective. So that it can be done, it just takes longer.
Okay. Here's another question here about repairing texture that has been lasered. The old school method is to scrub it out, and usually welding isn't necessarily an option due to acid burn rate. What are your thoughts on that?
So that is, I'll say, part of the trick of the trade, but it's something that we do all the time. So yeah, you typically have to scrub out an area, especially if it was, let's say, like a geometric pattern. So it was definitely probably done via laser. We would want the CAD for it again. And then we would need to be able to figure out, is there a feature where we can use as a hard stop in here so we can scrub out and then come back in there? Or if there's not a hard feature we can scrub out to, we'd have to probably take the whole thing out and then start over again.
Okay. How about, John, lead time? What would your typical lead time be to texture a part?
We're probably, I don't know, 3 to 5 weeks, something like that right now. But like Rich alluded to, typically what happens is we get the steel in and the customer needed it 3 days ago. But if that's not the case, we've got some heads up, you know, 3 to 5 weeks, probably about right.
How about you, Rich? What's your lead time?
Typically, right, our lead times right now currently are sitting around for nickel with no masking, right around 6 work days. Chrome's a different animal because typically an anode needs to be constructed, so you're looking right around that 10-day area. Depending on our workload is whether or not we can, you know, maybe offer an expedite service to trim a day or two, but that would be it. The day of you send it in and I want it tomorrow is usually doesn't happen anymore. But we'll definitely work with our customers to see what we can achieve to get it, back to you. Because we understand, especially myself, being on all sides of the fence, being a mold maker, building stuff, and then being a molder who had to run stuff, and you're crunched for time, and you're always pointing the finger at somebody. So, unfortunately, it's the plater because they're taking too long. So we try to mitigate that pain and do whatever we can to help our customers.
And to pile on here a little bit, I'll say the 3 to 5 weeks is being conservative. It, like you said, it depends on workflow. If we're a little slow, then we'll get it turned around for you in a couple of days, just depending on how long the burn is. But 3 to 5 weeks is pretty canned answer for us, with turnarounds typically being faster than that, to be honest.
Is it advantageous for the customer to send in the CAD file before you get the material?
So what we want to do is, while it's on the truck or being packed up and shipped, send us the CAD, let us start having those conversations with you so we can do all the programming for it. So when it hits the shop floor,
ready.
we can dial it in. Okay, we're good to go, and put it in the machine.
Yeah, that's important.
Yeah,
that's important. Anytime you can save and give the information up front to, I'm sure, Wisconsin Engraving and even us. A lot of times what happens is resins. What kind of resins are you running? We need to know these things, because if you're running a chrome, you say, hey, Rich, I want this chrome plated. Well, and then we ship it to you and you run a PVC material. Well, guess what? You're going to run that chrome and it's going to last about 4 hours, and then that chrome's going to be gone.
Right.
So these are things, just open that dialogue with either your plater or your texture house, and just make sure that you're communicating even if you don't think about it, or you think about it an hour later, shoot an email, give a call.
Please.
These are things that are important. We try not to have rework, just, but we want to, prevent, any delays if possible.
100%.
Do you folks offer any kind of pickup service or delivery service at all?
We do, yes.
We do within a 50-mile radius of our shop. So if you're in the Chicagoland area and just touching Northwest Indiana, we will come and get it.
I'm not sure what our radius is, but probably Chicagoland for sure, and then obviously Wisconsin.
Okay, here's a question for John. Is there a way to achieve a knurled pattern while keeping a polished look on aluminum?
Ooh. Maybe. I'm gonna go the hard maybe.
The hard maybe. That's good, because I was just thinking about it. I'm like, how would we do that?
It'd be something we could sample, but I'm gonna stick with the hard maybe. Until I know, I don't know.
Okay.
Sorry for the cop out.
Well, we have his name and contact, so you could probably circle back to him if needed.
Okay.
Perfect.
Well, that looks like that's all we've got for now. You guys did a great job.
Any other questions for anybody?
What's that?
Any other questions from anybody? No?
Last call.
Last call. Well, before we go, I want to thank John for coming out. We have a good relationship with Pete and Tom and you folks over at Wisconsin Engraving. In this partnership, this is something new for us, and we were thankful that you were able to come out.
No, thank you for having me. It was great being down here.
Yeah, it was a good time. All right, Rich, are we signing off?
Yes, sir. Thanks for everybody for attending. We appreciate your time, and I hope everybody has a great afternoon.
Thanks, guys.
Thank you. Bye-bye now. Enjoy the day.